Okay, so what we did in the last session is we created a grep in dir method, and for now we are doing it in a synchronous fashion where we are getting all the file names inside the directory and then passing it on to the grep function. One by one, and then getting all the results in a single huge slice and then returning it back. So last time we had tested few cases where directory was not found, or there was an empty directory, and which corresponds to this dir1, dir2, and dir2 is a single directory which has another empty directory. So I'll probably start with dir5 today because that is simpler, having one file inside it. I've already created these directories beforehand, and this contains the same data which we had in this test data.txt, which we're using for the grep testing. So one more thing that I found is this defer file.close. If we put it over here, what happens is unless this whole function returns, the files won't be closed. So let's say if we had 100,000 files, so none will be closed until this whole function is complete. So I had to read about this after seeing this error squiggly lines. So one way is either to wrap the functionality inside this loop into a function, and then which will close it after every single iteration. Or what we can do is manually close it at the end of the loop. So the program won't have to wait until the whole function returns. It will close the file after reading it. So does that make sense?
Yeah, got it. Makes sense. So anytime we have a for loop and we are reading files in a for loop and opening file handles, imagine file handles or database connections or any third-party API calls, we always worry about things in for loop. It's in a way, in database terms, it is called a n+1 query problem. Okay, what that means is typically you are n+1 query problem and what we are talking about are kind of different terms, but they're related in some way, right? The challenge is here is that when you think of for loop, always think 0, 1 and many cases, right? So if it is 0, then the for loop won't even run. Then we are still okay because there won't be any file handles that are open. If it's 1, then it will run only once and we are still okay because a single file will be opened, the data will be read and it will be closed. But if it's many, and by many you have to literally think like millions, right, in terms of scale. So if you are going to have million files, then are we going to open million files at the same time? Like os.open will actually result in a system call on the Linux kernel internally, and we will get most likely we'll get a panic or we'll get an error that file descriptors are no more there, like I can't open any more files, etc. So in that case, we almost, like we discussed in the last call, we almost have to limit the number of concurrent open connections, or how many files you want to read in one go. So we'll most likely end up implementing some sort of either queue or some sort of data structure which will have a window size of 5 or 10 or 50 or some n number of files that we can be opened at the same time. Does that make sense?
Yeah. Okay.
Yeah. So for now,
with this,
go on.
Yeah. So with this approach also, we have one more error condition, right? In the grep. If grep returns error, then this file is not going to be closed because it is continuing the loop.
Yes. So we'll have to close before continue also, right?
Yes.
Yeah. So actually it makes sense to close the file properly. One option is to do it in a go routine, right? Like as a anonymous go routine function, right? Can you actually check what IntelliJ or what Golang suggests? If you just have a defer file.close in a for loop,
nothing.
There is a squiggly line. So does it suggest anything? Can you press option enter? Click on the defer and then option and enter. Okay, no inspection. Okay, all right. Or maybe option enter on the close file.to close part. Yeah. Yeah. So rapid ending in a closure. Ignore.
This close returns some error. That is
correct. That we are ignoring. So
I found two solutions. Either close it in the end of the loop, but since we have multiple exit points in our loops, we'll have to close it again at each point, or to wrap this in a function and then close it.
Correct. So what actually we need is a reader to grep. So
Right.
we can, I mean, one option, probably not a good option or whatever, but one option is to read the file and like write a function which basically reads the whole file, returns the contents of the file in a slice of strings.
Okay.
And just use that in a grep as a string reader or whatever. Like that is one option where we can, yeah, I mean, we take the thing out of, I mean, we break it down into smaller issues, smaller problems, right? Like we read the file completely, but that will mean we are reading the file completely in memory.
But would that affect the STD in grep?
That so in Go, there is a thing called string reader, if I'm not wrong. So we literally read the file contents in memory in string and pass the string reader to grep function because it expects the reader, and a string reader is a reader.
Okay, understood.
That is one
Shall we try that?
hacky way. Yeah, I'll have to look up the string reader to make sure that it behaves as expected, etc. So I would say let's keep this point open for now. Maybe add a to do or some place somewhere, and we can, yeah, like add a to do to fix this basically. Got it. Yeah, this is useful.
Shall we move on with this dir5?
Yeah, I think let's do that, because anyway, again, we have, with other test cases that we have, we don't have 1 million files to grep into, and we also don't have a file that won't fit into the memory. Like we are not grepping 2 GB or 100 GB files. So the problems that the code has won't even be surfaced, like won't be picked up by our test case. For that, we need like things like load testing or stress testing kind of mechanism. Okay. So for now, we'll just do with the normal test driven development with these kind of tests, small tests, example based tests, and we have identified this problem, so we'll fix it later.
Okay. Fine. Okay, let's create a new test case. Containing one text file. This is same. dir name should be dir4 and 5.
So again, we can have two separate test cases for the single test file. One is content found and one is having found some matches.
Okay.
The 0,
so
1
one test case, yeah.
One has like one is positive, one is.
Yeah. Or if we can, now this is where test duplication, right, is what you will have to worry about. The kind of typical rule I try to follow as much as possible is one test case should test only one functionality. That is one. And the other rule or thing that you can try to follow is if something is changed, ideally only one test case should fail. Ideally, again, like that's a rule that you can aim for. What that means is if we mess up or if there is a bug in the grep functionality, like if you go to main.code and grep.go grep function, we have that if condition, right? If something contains something, and then that is where we actually append. So this is the main logic. If there is a bug here, like if we change this line or whatever, like if we add a not contains or mess it up, basically, ideally only one test case should fail. Ideally, again, that way we know clearly like what's the problem and how to fix it. If for some reason, if the same functionality is tested by multiple test cases, right, then what will happen is if there is a bug, then multiple test cases will fail. which is sometimes okay, but why would you want to have duplication of test data, right? Because tests are also code. So what we should think is, just like we want to avoid duplication in our code, we should avoid duplication in our test code also, because the test code is also a code that we write. So to to counter like the point that Kalpesh raised, it's a good point, but one way to other think about that point would be to, is this functionality already covered by some test case, the 0, 1, many functionality? If it is, then we can skip it as part of the recursive part.
Okay. I think we had covered this in.
Yeah, in the first test, I think we have covered that. So we can cover only one of them.
Non-existent match.
Correct. Only we can cover only one of them, which is like maybe multiple matches. So again, here the logic that I typically try to follow is, if it's an array-based test case, then ideally I would not repeat 0, 1, and many case the second time. I would only test the many case in that case.
Okay.
Right? Like because the return type is an array of grep results, I would expect that at least there are 2 or 3 matches.
And what makes sense over here is this 0, 1 or multiple matches belong to the grep functionality, not to the grep in dir, right?
Correct.
Right.
So testing it for grep makes much more sense, because we know that this functionality is working. So now we can test just for directory matches.
Correct. Agree. In some case, the point that Kalpesh says is also important, that we want to test duplicate. We want to actually have some duplication on the test case. Like, so don't take this as a like rule or as a gospel that we should not have duplicate test cases. It is sometimes okay to have duplication, and that is where the art part of coding really comes into picture. Like, as long as there is not too much duplication. Now you could argue what is too much. Like, is 1 too much, 2 too much, or 100 too much? I think 100 is definitely too much. Everybody will agree. But once or twice, yeah, I mean, there is a gray line there, right? So in this specific case, I personally would vote for not testing it again, but that's again very personal preference. I'm still okay if someone wanted to say that we should actually test it again. So 0, 1 many case, I would be fine with that too, ideally, because one, like the context that I'm trying to apply here is, one, the program is like small. There is the reason actually I'm saying we should not test duplicate because of these things. Like, the program is very small, so if things break, we want ideally to only one thing to break, right? And the other is, there is one other small eye that I keep on a metric, which is code versus test code. Like, if I have a code of 100 lines, what is the number of lines for my test code, right? It is typically either 1 to 1, or depending on, again, the language framework, how much you want to test, are you test driving, etc. It depends. But we would also don't want to just go overboard with test cases, if that makes sense, right?
Yeah.
Because testing code is also a code that we have to manage and maintain going forward. So it's almost like double the code typically. Like, if our main.go is like 200 lines, the test code is also already 200 lines.
Yeah. Okay. Let's go with this one then. dir4, dir5. And we need to create something for the expected value that we are supposed to get. Should I create it separately, because this will be cumbersome over here?
Yeah, let's
we are getting a grep result. Since this one has only one file, I guess we will only have one entry over here, right?
Yeah, grep result will have only one entry, but as we said, we should have the multi match test case. So the result array inside this will be multiple entries.
Okay. Okay. What was the structure for this?
Yeah, so IntelliJ tells you like file name, colon, yeah.
File name is. Are we getting the whole file path like dir4/dir5 test3.txt or just test3.txt?
Yeah, so typically in grep, what happens is it gets you the path relative to the path that you invoke grep with. So if it was the absolute path, then it will typically give absolute path. That's at least my knowledge. If you start with a relative path, then it will give you relative path. What that means in this case, it will give you the full
Test
relative
data,
path.
yeah.
Test
One.
data.
Test data,
Yeah.
dir4, 5,
Correct.
and then file name.
Correct. That's the path it should give you.
Our result should be a string array.
So do we want to make it a multiple match like we discussed? Because it's a array of strings. So we can add maybe one more line, I guess. Or we can just search for the word file or and then expect that both the lines are matched in the file, whatever, something like that.
That also makes sense. Okay, and error will be nil. Let me run the test. Did pass. Let me try changing this to see if expected on the session file. What? Yeah, so it is passing for the correct reasons.
Nice. Okay. Yeah. So the implementation is already complete. Nice.
Right. Let us try for this dir4 now, right?
Yes. So here one more thing that I want to highlight. If can you open terminal in Golang and just run grep grep command. So run grep on test data / dir4 dir5 test yeah dir4 / dir5. That's it. And actually run grep minus small r, like capital lowercase r, and then the directory name. And then at the end of it, just add file. Yeah. So what grep build? Actually, you can do file without the quotes. Not sure which shell you are using. Is it fish or some other shell?
Hey, this is item.
Yeah, but the kind of shell.
I think test data the /test.
Oh,
Acha, haan.
no.
Text
Yeah, okay.
search string should be first, and after that it should be a file path.
Okay, yeah. So no, minus r should, then there should not be any. So after minus r, there should be immediate next argument is the
Right,
directory.
the directory name.
Yeah. So grep this minus r this. Actually, other way also works if I'm not wrong. But let's see. Okay, yeah. right? So what you see here, what I want to highlight is the fact that you got the /test data dir4 dir5 test3.txt colon, right?
Right.
On the start. And what we also got is that file in red, right? So there is some terminal coloring also that is happening. What
Correct.
we are doing as part of our, because we are doing it via test driven development, we don't even care about this representation.
Right.
If you think about it, like what we have as a result is I found the string and the other string. We just are matching the two strings. Nowhere here we are saying that they have to be of a particular color. They have to be preceded with the file name and a colon. Each line has to be preceded with that, etc., etc. Right? All these are not tested as part of it. Now you might say, okay, I mean, why are we not testing these? So I'll go back to the same argument that I made the other day. Is with TDD, what you get to focus on is the real thing that matters. And it almost gives you hints and it guides you to focus on what really matters for your code. If you think about it, these are just conventions, right? That every search result has to be preceded with a file name and a colon. Every match, exact match, has to be highlighted in red. Like someone came up with these conventions, and the fact that someone came up with these, that means they also can be changed tomorrow.
Right.
Right? I could say, no, I don't want red, I want yellow or green, or I don't want any highlighting. I could say I don't like colon because it confuses me whether the colon is part of the line or not. So I want like a space, or I want nothing in between them. I just want the file name, or I don't even want the file name.
Okay.
Right? Or I want only one file name and all the lines in that file should be returned. And then if there is another file name, there should be a new line and another file name, and then all the lines matching in that file. So what I'm saying is these representations can change, right? And what TDD forces us to do or helps us to do is don't worry about these representations. These can change. So you worry on the core assertions. The core assertions are the exact match has to be returned. What you do with the match, how you represent it, whether you write it to a console, file, TCP stream, printer, none of that matters. Like that's all external parts, right? Which may change in future. So this allows us to really focus on what really matters for the core domain, core problem domain. And we don't have to worry about the externalities. Does that mean you don't write tests for these? The answer is no. If you have very clear idea on the specification that this has to be highlighted in red, and that is part of a acceptance criteria or an expectation from business, then you might as well write a separate test case for exactly this representation. But if we write the code via TDD, what will also, it will help us is that anytime this convention changes tomorrow, our core functionality will not change because we are still returning the result from the function, right? So
Yeah.
there is probably the way we will end up writing this implementation, if we want to highlight red, green, whatever, is we'll probably have a separate function which just takes this input, the result, and adds the color, adds the like the prefix and whatnot, right? So it helps us decouple the changes, decouple the responsibilities from the code, and it naturally makes our code more towards solid design principles like single responsibility and things like that, right? So that's the good part about TDD, that it helps us focus on what matters and also makes it very apparent what things don't matter. And if you want to still write test cases, you should, which you should, but the code should be, the design of the code should be such that you write a function that accepts this input, the result as an input, and returns maybe a string, right? And then you write another function which just whatever the string is taken, it just print the strings to std out. So it almost naturally forces you to write smaller functions that are reusable, that are doing one thing and one thing well. Cool. Yeah, that's all I wanted to highlight.
Okay. Okay, let's write another case for dir4.
At that point, we could also make a small commit without like we can choose to commit without pushing. That's also okay. You added one more extra copy paste, so just undo that, I guess. Yeah. So again, the one rule that we follow, right? Every time there is a green test case for the right reason, we make a commit, and every time we have a green test case for the right reason, we also look for opportunities in the code to refactor. Over time, right now, I think I didn't touch upon that point because we know that there is no code that we wrote, so there is not much thing to refactor anyway in the code or in the test code also.
What change we did in the main.go?
Acha. Let me check.
The defer to do, I think we added.
Oh, okay.
Yeah, just that.
Cool. Yeah.
Yeah, oh, cool.
Okay.
So it will almost be a copy paste of DR5. The DR5 part will be copy pasted.
Yes, but this will have multiple.
Correct, and it will have other DR4 two files from DR4. Yeah.
Okay. So 3 total, right?
Correct. And because now here is another question. The order, we know that the order in which the file path.walk directory works is depth first, right?
No, the lexical order also matters. Since
Correct, but it's a depth first. Oh, it's a
Yeah,
lexical
so
plus depth first. Okay.
yeah.
in one
So
directory,
DIR5.
first the lexical order, if the folder is coming lexically first, then it goes inside that folder.
Got it. Okay. Yeah. So then in this case, it will be DR5 test 3 and then
Yes.
test 1 and test 2.
Right. So test 3, this is the one. Test. Yeah, 4. And, these is one. Test 2 contains just this one. Okay. This is working correctly.
All right. Nice.
Okay. So we are almost done with the test cases that we had decided before. What shall we move into next?
Yeah, is there there is nothing to refactor, right? Right now in the test and the main code as well, both.
Because we haven't touched the code,
Correct.
neither logic or the main.go. We just
Okay.
added some
Yeah,
text.
so maybe let's make a small commit and we then uh, yeah, we'll look at the code to see what we should do next.
Okay.
Cool. So if we look at the main code now, what all, so the next thing I think is to do the recursive implementation. That is one way.
Right.
Sorry, I mean the go routine implementation.
Yes, we can start that.
Any ideas on how do we do that? But is there a way to gradually introduce it? Right. So because the way we have written the test case are such that they return a result of like an array of grep result or a slice of grep result. That means that entire grep functionality or entire grep will complete first, or will only after the entire grep command runs we will get the output, currently at least.
Right.
So what we, there are two options that I see. One is we let that be the case as it is in the test case and in the code. So that means the API contract for grep in directory remains the same. The API contract doesn't change. That is one option. Or we change the API contract and we return results in a sort of streaming fashion.
Okay. I have a
I
question
think,
on that.
yeah, go ahead, Mohit.
Let's say if we keep the contract same, then the same issue that we're thinking about the ordering, what will happen to that? Because any go routine could return at any point of time and we'll be appending the result in the slice in that order, in whatever order the go routine comes up with the results. Then we can't decide for sure what the order is going to be like it was here in this case. We knew for sure that it will go 3, 1, 2, because walk is you know the ordering, but go routines you won't be able to.
Yeah, anyone has any idea on how to solve that, or what can we do in this case?
Lock on the channel.
I think maybe we can use the map instead of just having the slice. So that way, whatever we are getting from the function, it will return the map of grep result. And that way we can identify for which file the result we got.
Map as in something like map of the file name
And the grep result.
like this.
Yeah.
The file name will be duplicated because
Again it is it is duplicate.
So fundamentally we are talking two options. One option is we keep the semantic notion of ordering by keeping it still a slice of grep result, right? And we enforce that ordering some way by synchronizing or aligning the go routines, right? Or blocking on go routines, and only so it's almost like this, like there are 10 workers doing the 10 jobs at the same time, but each of them have their numbers, like number 1, 2, 3, 4, 5, 6, 7, 8 up to 10, right? Each of them are given jobs, and each job can take how much ever longer, we don't know. But when we assemble the results, we assemble them in the order in which we want, which is first guy, second, then the third, then the fourth, then the fifth. So that means if we are blocked on fifth person, who is the slowest, then yeah, we are blocked. Like we wait for the fifth guy to complete their work, and only then we proceed with the next sixth person, right? That will, so that is basically a concept of blocking and ensuring that the results are assembled in a predictable and sorted order. That is one way. Or the other way, as Kalpesh is saying, why do we have to preserve the semantic of an array? Can we break the semantic and say, look, grep can return results in any order? We don't know. We don't care. So now this is a change in the business requirement in a way, like purely if you think from grep, like contract, whenever we change something from order to unordered, it's a breaking change, right? Because as a client, I could have depended on that order earlier, like my results being in particular order. I could have been dependent on that order. The fact that we are changing it right now, that means the clients will have to also adapt that to that new notion. Now you might say, okay, there are no clients right now. What are you talking about? And you're right, there is no clients right now, but this is a design decision that we have to take ultimately, right? Both are okay, like there is no harm. What that also means though, if you, what is the side effect of changing it to a map purely from grep executions? Can anyone think of that idea? Like if we make this a map and not a slice, what will happen to grep invocations?
I didn't get the point where you were saying the file name will be repeated.
Yeah, because grep result already has a file name. So we can, if we are having a map of file name and a grep result, then we can remove the file name from the grep result.
Okay. Oh, in that sense.
Yeah, purely that. So my question, coming back to my question, was that what will happen to multiple invocations of grep if we change the result return type from a slice of grep result to a map of file name and a grep result? Any thoughts, any idea?
I'm not getting any.
So what I'm fundamentally asking is, what's the difference between map and a list?
The order wouldn't matter anyway.
So imagine this program, like let's say we change this to a map. Okay, the entire stuff, we fix the test cases, we did everything that we wanted to do. All of this is done, and we actually package this and ship this as a utility. Okay, and there is a grep binary that we have, which is my grep. Okay, I'm using this binary to run on a particular directory. Okay, I did a -r whatever, and then I got some results. All right.
Okay.
And you have the same directory structure. You have the same grep command. It's like literally like the copy paste directory, or even forget some other person. I invoke this command today and I get some results. I copy paste them. I invoke this command one more time. What is the, like I'm almost giving you the answer right now. What's the difference between these two executions? Is there any difference between the executions?
The order in which the result will be shown to you will not be consistent.
Exactly, right? Each time I run grep, I get the same results, but in different order. Or I could get in different order. I'm not saying I will always get, but there is a possibility that each invocation of grep will be like random output as far as the user is concerned. I mean, not random output, but randomly, if there are 10 items, they are randomly arranged every time. Does that make sense?
Yes, but if we use parallel grepping and we don't implement the solution that you said about assembling the output in a fashion in which they were invoked, then in that case also we are getting random ordering.
Correct. We are getting the same problem. But so that's what we have to, like, one is, this is again, that's why we are saying that this is a change in the business requirement or the contract. Right now there is no one consuming, so there is no contract as such. It's only theoretical contract. But if you think about it, it's still a contract. That means ordered set or ordered list is different from unordered list or unordered set of items, right? So Now here is where, I mean, again, because this is a made up problem, we can choose to do whatever with the requirements. We can choose to say, look, we don't care about order. This is what it is. Like you are going to get multiple, every time you run the grep command, you may get the results in different order. This is how it is. Like move on. That could be the way to do it. I believe grep doesn't work that way though. Grep works in a predictable fashion where no matter how many times I grep the same directory, if the files and the directory and the grep command is the same, I get same results in the same order. That is what my guess is. Like I could be wrong, but that I believe that is how grep is implemented. So it's really up to us at this point to make this matter more like interesting. We could choose to say, look, we should preserve the order. So that will force us to also learn more about blocking and assembling results in particular order and whatnot.
Yeah, I think
One way
that
I
is
can
the
think
better
of is the way we are appending this result. We are dependent on this walk dir function. So what if we pass this result, where is that? I think a list of files, right? What if we send this back again to the wherever we are printing it, and then we can traverse the map through this. This will be the key set of keys. So this will be consistent with walk dir. So every time we can predict how the output will be.
Correct. That is what we are almost like saying the implementation of how we will actually implement the blocking fashion, right? That is exactly how it will be. That imagine again the workers scenario that I talked about. The worker names, like if there are 10 workers and if I give each of them an ID or a number, right? That is the logic. Like this array that you see, the list files return array, that is how we actually assemble the results. So we preserve this array, and wherever we are assembling the results, we assemble them in only in this fashion, in this order. So almost like for every file, this is where we will probably need a map. Like it's almost like for every file, there is some go routine which is going to produce results, and we are going to block on in a for loop. We are waiting for the results to be assembled in an order in the loop. I mean, in the order in which the files appear in this slice of array, slice of strings.
Right.
Sorry, my bad.
Yeah.
Right.
Yeah.
Other thing we can do is we can have the map inside this grep directory function itself, and so that way we will not change the signature. But whenever we get any result from the go routine, for a single file, we will just add that into the map. So that way we don't need to wait for others. So we will add the insert the result into the map, and then later, as per this order, we can arrange that and return the same slice of string. So that is also another way.
Right. That way we won't have to block for correct ordering.
Correct. Yes.
Yeah, there will still be blocking involved for waiting for all
So
routines to complete
fine.
though.
Correct. So that waiting will be there, but the waiting for the order, that will be not be
correct. As the results come in, we will just append them into the map and build that structure.
Correct.
And once the whole structure is built, we will return the structure in the order in which we want them to be returned. Yeah, that also makes sense actually. That is
that blocking is actually because the way we are testing this. If we had to print it out, we could have done it at that point of time only. I mean, without waiting.
No, we will still have to assemble them in the order in which we want them to be printed, right? Because in printing also we are saying that, okay, so fundamental question is, do we want the results to be predictable and same across multiple invocations? The answer to that is yes. If the answer to that is yes, then we have to assemble the results in that particular order, right? That means we have to block for the entire result to be computed and then assemble the results in the order that in which we want. Like how we do it is up to us, but there is no getting over the fact that, yeah, we have to assemble the results in a particular order. We can't just return them as they appear, because that would be unpredictable order.
Right.
Yeah, so given like we have 10 minutes or so, what we can do is write down or think about API contract, pseudocode, that kind of stuff. And the next time we can try to actually implement some of these stuff.
Okay.
Right. So the test cases won't change then. That is what we are saying again, that no matter what happens inside, from the test point of view, all the results are assembled in one go and returned to you.
Right.
Right. That is again one important design decision that we have taken. Whether it's right or wrong, it's really up to context. We are not arguing that, but that is a design decision. It's very important to know that this is a decision we have taken. Why this is important design decision is because this, if tomorrow someone runs grep on a huge directory and it takes 15 minutes to assemble the results, they won't get anything until 15 minutes, like and everything that has to be grepped has been grepped.
Right.
Right? That's an important design like this. And so the API, if I were to assume that, okay, give me the results as they appear, why are you waiting for entire thing to complete? Like, why can't you, in fact, if you think about it, by making the program parallel, like we're using Go routines, we have actually, I mean, not really slowing it down, but you get it, right? Like, because of this design decision, even that is what is present right now. So the design decision is already been made by us in the previous call, that we will always return a complete like grep result slice. That means you have to wait till the entire search results are available to are computed, right? Because there is no way to return one item multiple times. Like there is one which is Go routines, I mean channels. So if we were to use channels in the test case and in the code, then we would be able to return multiple times, as in pass, send the value as we get. But that is not what we did. So that is a design decision that has already been made. Just being aware about, and it's a very big design decision that we have made from pure, because this is a learning like exercise and we are not going to use this in production, etc. It's okay. But purely in terms of usability in real world, that is not how it will be implemented. Like in real world, people will say, look, I don't care internally whether you use Go routines or whatever. I want results as soon as possible, and I want them in streaming fashion, like as they come. Because I'm done looking at results and I might just press Control C and get out of the program, right?
Right.
But in this case, we are saying no. If you ask me to search through the home directory, you have to wait for like 5 minutes, 10 minutes for the entire result to be computed, and only then I'll tell you the entire result. That also means the entire result output has to also fit in memory.
Right.
That means we can't grep on bigger files and things like that, right? Those are the non-functional requirements that we are violating, especially when it comes to high scalability kind of systems and high throughput systems. So in ideal, like real world, for toy exercise, this is fine. But in real world, we will end up having to return results via channel.
Okay.
Yeah. For now, this is okay though. Like we can have the channel abstraction within and assemble the results, or whichever we're using, map or blocking or whatever, and still return all the results in one go. Later, maybe if we really are curious how we want to do this, then we can write a separate Go implementation where we return results via a channel.
What I understand is we have a trade-off to make. Either we choose the correct ordering or we get the streaming fashion, the outputs in the streaming fashion. Am I correct?
Yeah, right. With the channel or the streaming system, the order will be not same at every time.
Yes. Whichever Go routine finishes first, that will display
Yes.
the output.
Correct.
We can, however, do the ordering also in a streaming fashion as well. What we will end up doing is we will end up blocking. So it's almost like there are 10 jobs or then 10 things that you have to do.
Mhm.
And imagine the first file is itself a huge file, okay, which takes like 10 minutes for, let's say a few seconds to assemble. But the other files and lexicographically, that is the first file that actually happens to be the first file, let's say. So uh, in terms of purely, if you run every file in a Go routine, then the other Go routines would have already finished.
Right.
But if we still are hellbent on the order, which if we want to be deterministic in grep, then they will not be able to take the results from those Go routines won't be printed until the first Go routine is complete, reading completely consuming the first file, and its results are printed first. Only then the second Go routine's results are printed. Does that make sense? So I don't think it is mutually exclusive of sorts. It's how we want it to be. So if we want it to be ordered plus with Go routines plus streaming, yeah, we can have that, but that is the trade-off, as in you will have the code will still appear to run slow.
Right.
Well, actually, maybe slow is not a right way to say. You get that, right? This is a classic queuing theory problem. A queuing theory problem is or head of line blocking kind of problem. Imagine you go to McDonald's, right? And the customer in front of you has a huge order, like 50 items. So even though your order is like done, you're on a different booth or different counter. If the McDonald decides, look, this customer came first, so I'm going to serve his order first before I serve other people's order. Then we are anyway, even though our order is ready, they won't serve us because they have to first serve this customer.
Right.
So serving customer is actually like printing the results of grep for that particular file, which is like 2 GB in size. So other files are all like few KBs. Their results are grep and the results are already done, but they are not printed to the console until the first file is printed, because we want the results to be in lexicographical order. Does that make sense?
Yes, it does.
Yeah, so it's up to us how we implement this, or how we want it to work. To again, in this case, to make it simple, we can relax the ordering criteria for grep in that case, especially if you are doing streaming fashion.
Okay.
So if you're doing streaming, we say, look, we don't know when and how results will be printed. They will be printed as they appear. So if the first file completes, like the smallest files will complete first, you will get those results really quickly.
Right.
The way real grep, however, the way it works is it goes in that lexicographical order, meaning that if it finds a particular directory and if it has 100 files and 100 directories or whatever, like the nested structure, its contents are all grepped first, and then only like the other grep output will be printed.
Okay.
So yeah, the one way to see what we want to implement is also to look at actual grep, like how it works, right? And we can choose to simulate it exactly so that we are compatible with grep in some way, or we can choose to deviate because this is anyway a exercise. It's not really a production code. I mean, it is production code, but it is not. The requirements are flexible.
Right. Does grep return the whole array of matches, or does it, once it hits any single line, it will print it out?
Yeah, it will print it out as it appears, is what I feel. That's how it works.
Okay.
I haven't looked at the actual grep implementation, which is probably in C. I haven't looked at that, but having used grep multiple times on smaller, bigger, large kind of files and multiple directories, millions of files, etc., this is what I've observed from outside as a client of grep, that it starts printing the results as they appear, but in the order, in some particular order. Because if I run the grep again, the same command, it prints the result in the exact same order.
Okay.
So it preserves the order and it prints the results in a streaming fashion, as far as one can tell from outside.
Okay. So what are we deciding on? Ordering or or streaming fashion?
I'm okay with either. To keep it simple, we can do streaming. The problem with streaming though would be how will we assert in the test case if we don't have order?
Yeah, actually assertion will be changed the
Yeah.
so instead of in the single line, we will have to have the for loop there.
Yeah, or we will just have to assert that whatever results we are getting is contained in the, like it's
Right.
almost like contains thing.
Contents, correct.
Yeah.
Can we compare maps?
Yeah, we can compare maps otherwise. Yes, that's another option.
In that case, ordering won't matter.
Yeah, but map deep equals, not sure whether it deep equals takes into consideration order or how it works. You know what I mean, right?
Mhm.
Does it match? So it's almost like getting a key and its value and checking the value is same as the value that is found in my expected map. It's almost like that.
I think the ordering doesn't matter in case of map.
Okay, yeah, then we can use deep equals for map.
Okay.
So maybe let's write down these design decisions somewhere, as in like as requirements of sorts, that this is what we are assuming or this is what we are agreeing on, so that next time we are very clear that okay, this is how it will be.
So we'll
So streaming results.
assemble the results streaming fashion.
Yeah, so actually there is no assembling then if it's streaming and without ordering.
Assembling as in putting in a map.
Okay,
So-
yeah.
And as soon as one go routine finishes with the result, it will put inside a map.
Okay, so the API contract is still what we have right now, right? There is no channel that we will have inside the grep in the
It's
app.
going to change. We'll have to pass a channel.
So okay, so if it's a channel, then you don't really need to assemble. Whatever go routine completes, you just append the result into channel, right?
Yes.
We don't really need a map then, or we don't really need any assembling then.
But how will you return the data from grep in dir to compare it against something in the test?
Yeah, so there is no return data, like there is no return thing. Then the message will be put into the channel, and in the test case we will read it from that channel.
Okay.
You get it? Like channel is a synchronization mechanism.
Correct. And in the test, whenever we are getting any message or any message in the channel, then we can check that in the expected output in the test case. So we have this array of expected array, right? So we can do a for loop for each and every message and then check whether it contains that message or not.
Yeah, instead of even for array like expected as an array, I would put expected as a map itself.
Okay.
No, but in that case, we will have only one result at a time, right?
Yeah, so the result here is where it gets tricky, or how we want to do it. So in the result, the channel type depends on if the channel type is a tuple of file name and the results, then tuple or a struct of file name and result, like the grep result is a channel type, then we can just get the file name, and in our expected map of file name and results for that particular file, we can just compare the array.tip equals. You know what I mean? So imagine a map of file name. The key is the file name in the map, which is a string, and the output or the value is a correct, perfect.
Right.
And what we get from the channel is a grep result. A grep result is nothing but file name and slice of string. So it's almost like a struct of that, right? So from that grep result, we can get the file name, and we will check map dot get me the result for this file name.
No, but so number of keys, I think deep equal will check whether all the keys are matched or not, right?
Yes.
No, but we are not getting right? We are getting results one at a time. We are not getting all of them at once.
Right.
won't use deep equal in that case.
Correct.
Correct. We will when what we get from the go routine or from this function, our grep function, grep function is a grep result, then not even a slice of grep result, because every time we call it, we get it, we are going to get a file and
For one file, right?
yeah, for one file. And then we compare grep result dot get the file name, get that file name from the map. We will get the
okay. Now I
matches
got
of
it,
that,
what
and then we
you're saying.
compare.
Okay, got it. So the map will be only for in the test cases, not
Correct.
as a part of the result. Okay.
Yeah, not as a part of this. Yes.
I see.
Okay. But in this case, I have a doubt is, how are we going to check if all the keys have been validated, or if extra keys are not left, or something, some extra.
Yeah, I get it. I was going to come to that. So, I mean, yeah, I don't have a ideal solution. We can add a hacky solution.
Another map with.
No. So what we can do? So map is mutable, right? We can have
remove the
something
entry from that map. Once
or
it is
maybe
matched,
or maybe mark that as a matched one or something like that.
Okay.
Yeah, like it could be that, or like
Removing it. Yes.
ugly way would be to remove. Once we have a match,
it.
then we remove, and we expect at the end of all the matches,
Map
we
should be
expect
empty.
that map should be empty.
Yeah.
There is no extra, and there is nothing missing also, both sides. Yeah, it's does that make sense?
Yes. The removing case, right?
Yeah, removing is one option. What we have to also do, right? Like we are taking this very seriously. I mean, we should, as in the test cases and how we do TDD, etc. But at some point, you have to also have a thinking that, look, tomorrow when we read this test case, is this going to make sense to us or not? Right. So I feel the deleting and then ensuring that this is exactly what we're getting, etc., are just guards or things that we can drop and it is still okay. Because if you think about it, we are not going to write anything specifically as a hard coded in the code to ignore a particular file or to add our own random results or whatever, right? Does that make sense? Like in the code coverage, if you see, the only way we can get extra data or only way we can get missing data is if we have a specific case inside the actual code, that if we get a particular file, then ignore it, or if we get files of this extension, then just, I don't know, add some extra lines there and whatnot. So at some point you have to also trust that you are the only one who's writing the code, and you know this functionality or this way, this output, weird kind of output, is only possible if where someone actually were to go and modify the code and add some hard codings. And because this is a closed source code, like this is not open source code where anybody can like try to raise a pull request, and even in open source there are maintainers and whatnot, right? It's not like open source doesn't mean everybody has a commit, right?
Right.
So in this case, I would try to also favor readability and simplicity of the test case than 100% assertion. As in, you get it, right? Like okay, keep it. I mean, keep the just that check that it contains. You don't have to delete the keys and ensure map is empty afterwards, etc., etc. That's probably a bit being too defensive in the code. Right? Nothing wrong with that. It's a valid approach. But the downside of that, 5 months down the line, if you were to look at the test case, the readability will be hampered, and we will not know as to why are we removing the keys from the test case, like what's going on here and whatnot, right?
Now I'm supposed to think about edge cases if we are deleting. I mean, if this particular thing is going to fail or not. I mean, will it not be able to confirm all the cases?
Yeah. So correct.
But I have
So
to think about the test case also now.
correct. So that is what we have to, and that is where the art part of software comes into picture. Like there are these rules, but you need to know when these rules can be broken or should be broken. And again, there is nothing right or wrong here. Like some people might say, no, I don't want to break the rule. I want to write this test case this way. It's also okay. But all we have to ensure that all of this doesn't come at the cost of readability, which is the most important part of a test case. Because also we have to understand that the tests that we write are a form of documentation. In fact, they're a form of living documentation. Like that, the tests are a way to say that this is how the code behaves. This is what the code does. So making it more readable, more approachable is also a very important aspect. But yeah, we can do the deleting if we want to. I mean, that's one option. But that is where I felt if I actually were to imagine that test case being written, I might find it confusing after a while. Like why this delete or how or whatnot.
Right.
Anyway, cool. I think we're already over time. So yeah, next time we can try to implement and merge, implement these things. Yeah, I think it's just some approach part that we've added, like 2 or 3 lines. Okay. All right. Okay, great. I'll stop recording. Thanks.
Yeah, thank you.